Hello, everybody. This is the first Boss Code Review session, a weekly session to go over Boss components, smart contracts, and give an opportunity for devs and people building in the ecosystem to do a walkthrough of code. And so on today's episode, we have Harry, who built a lot of different things. One of the first things he's going through is a bot on your social, which is very interesting for a lot of you who want to automate things. But yeah, if you want to introduce yourself and what you're about to break down for the audience at home.
All right. So, hello guys. I worked on something called the Near Social Bot. What this bot does is it allows you to automate replies and comments on the Near Social platform. Like, let's say you want to do some marketing for your campaign, or last week's happened, NDC elections. So Near Social Bot was used in a lot of that, where people can be pinged about how they can vote. I mean, it's usually can be used as a tool to promote a cause, or promote something across the Near social media platform.
Yeah, and can you kind of like outline how this goes? So going over this, what existing bots were already there that you referenced? I know there is maybe Mr. 27 and other resources. So can you kind of uh outline that? And then for people who don't know, can you kind of explain what Near Social is, and then what the social DB is, and kind of how you began to think like to automate this?
Okay, all right. So first, we can talk about what the Near Social platform is. So as we are seeing on my screen right here, this platform is basically a social media on the Near blockchain. It's very similar to Twitter, where you can write and upload images, and rather than the data being written to the database, it gets written to a social DB contract. So basically, there is a social DB contract. So let's say I make a post. Hi there, it's Harry. So when I post it, it gets posted to a contract, which we're just gonna see right now. So see, there's a Near Social contract, and as we can see, there's a social.near, which sets it to the social.db. So basically, near.social is a social media platform that interacts with the social DB contract to give you a Web3 kind of interface to interact with people.
Awesome. And so what would a bot look like? What would like, so okay, so how would you set up a bot for this? Right now you have an account. Every time you want to post, you're manually doing it. You're authenticating requests through the wallet. So how'd you go about automating this, and how is that all set up?
All right. So there are basically two ways of doing this, which I'm gonna get into now. So can you see my VS Code screen?
Yep, we can see it.
Awesome. So there are two ways, because it's a blockchain, right? We can run the bot in two ways. Basically, the first is a cron job way, where what happens is we run the bot every 24 hours. So what it does is it basically 24 hours interval. Yeah, so we basically run the bot every 24 hours, where what it does is it captures all the posts, analyzes through it, and it comments under the post which needs to comment on, and which it doesn't need to. And there's also another way, which is called the indexer way. So what an indexer does is, this is a kind of special use case. Indexer captures every transaction that happens on the blockchain. So what you have is an incoming stream of events. And what you can do is you can filter transactions here, which belong to the Near Social platform or social DB contract. And then basically you can comment under those. So these are basically, the two ways I would go about, like setting up the bot in near social.
And so can you kind of outline the specific use case? Because some people may just want to post, especially if you're a social media manager, every 1 day, every 2 day. But in your specific use case, you're actually listening for posts. And then based on what the post is or who the post is, you're replying to that post. So can you kind of outline that use case?
Okay, so the use case which this bot was created was really, unique. So what happened was in the NDC elections, what we wanted everyone to sign up to a platform which is called I Am Human, which is visible on the screen right now. What this does is it verifies your personhood. So what we wanted was, in order to run a successful election, we wanted more and more people to sign up. And most of the people on the Near platform existed on Near Social. So what we wanted was everyone who was making a post on the Near platform, we wanted to comment under their post to get engagement for the I Am Human platform. So the use case was, if you are a human, then you get a verified human kind of, comment. And if you're not a human, then you get a kind of comment which says, like sign up for NDC, sign up for I'm Human. So I'll just go into the code now, jump straight into it. So we are querying a contract called fractal, registry I'm Human Near, which basically has the store for all the, you get a special soulbound token when you verify as a human. So when you get that, we verify that. If you have that, which is being verified by verify as human function, if you have that thing, which we get in the is human variable, then what we comment is you are definitely a verified human. And if you don't have that, then what we do is we comment under your post, are you ready to be a part of Near election? Don't forget to register for I'm Human. So what we basically did is we kind of captured all the posts that happen on the Near social platform, segregated them into two categories, whether the people who posted were human or not. And based on that, we made a different comment under their posts.
Can you kind of go from the top? So you're building a simple JavaScript script, where so
Okay. So you want the complete code explanation?
Yeah, if you can do a quick run through of how you set up your environment, like how, I mean, some people at home might be confused about like, is there an account associated with this? How that was set up? How do you import near and things like that?
Right. So the entry point for this file is run bot, where we just run the code, run our JavaScript function. We import some environment variables which are used to basically set up the sign in for the account that posts the comments. So basically, if you see there are basically three files that are required for the bot to run right now. First is the near file, where we initialize the near account that we'll use to make the posts. So first, what we do is we log in with Near using the Near account ID and Near private key. You have access to those of your own account. If you want to run your own bot, what you can do is you can extract your own private key and account ID from your wallet and then initialize the Near, right? And then what you can do is this is basically an open source code that's provided by Near, where you initialize all the function calls and send transactions, this file. And then what you do is you also need to set up the social functions. So how are you going to make comments and like on the social DB contract? So this social file is for that. So there's a social class that we have like our post to make a post, and the function that we are going to use here in this bot is the comment one. So what we did was we posted a lot of comments under people's posts. So comment is the most recently most used function. And what we do is we also, now here's the special part. You can also post images under your comments using an IPFS CID. So what happens is when you attach an image to the comment body, how it will look like is this. So my IPFS CID is this, and it renders as an image. So if you see this, starts with BA, ends with JE, is the same IPFS CID that I have here. So it's pretty special. Like you can also, post, you have the ability to post your own media onto the comments in an automated way. You don't even need to upload it anymore now, once you have uploaded to IPFS.
And so what was the process for, like, because this is the same photo right now. It's not like usually when you make a post and you upload an image, there's an IPFS uploader built into the gateway. But you already basically took that and you're using the same image here. You're not, the IPFS uploader part is not part of the script, correct?
Yes, it's not. It's basically once the thing is you have to upload to IPFS once to get the IPFS CID, but once it's uploaded, you can just use that CID to copy paste that image everywhere under your comments. And then we also want to notify the users. So if you see my notifications, it has the bells, and the bells has some numbers, 3, which is GeoTV Botnier mentioned you in a comment. And I can go and view the comment, which directly relates to this. Now, how did I do it? I did it by appending the notifications array and setting this data. So what happens is I commit one time to the blockchain, and in that I send both the notification to notify the user about the comment and also the comment itself. So like two targets in one arrow. So we have the social file and utils. This is a special use case, like because see, when you make comments, you want to keep track of till where you have commented, so you don't double comment under every post. So what we are doing right now is we are keeping a state.json file. So for that, we have this JSON utils. So what it does is it stores the block height of the transaction. Now you may ask, some of the people new to Web3 may ask, what are block heights? Block heights are a way that we are able to index the blockchain. Like if you have like let's say talking the Web2 world, you have your MongoDB or anything, right? Each entry in the table has its own unique ID, right? So each unique transaction in a Web3 blockchain has its own unique ID, and that ID is called a block height. And block height is very similar to the timestamp. So as time goes on, the block heights increase. So we keep track of the latest block height that we commented. And now we go into the index file, to the runbot file, where the real magic happened. So what we did was we imported all the things that we need up on top. We declared the verify human function. Now what it does is it checks for the token. That's a proof of humanity that we have. So it checks for the token and returns it. This is the declaration of that function. Now is the real thing that happens when we start running the bot. We initialize our near. We initialize the social class that we'll use to make the comments. And then we also load the state. What the state gives us is it gives us the index, like where we have last ran our bot in, like which block height has it checked. And then we fetch all the posts that we want to fetch. So right now we fetch it from the signal state block height. And if we don't have that, let's say you're running it for the first time, what we do is we fetch the latest post from the blockchain and analyze it and set it as a block height for all further transactions to run on. Then what we do is we obviously, the current block height that we ran from, we we only want the blocks that are further, right? Further from the one that you previously indexed. So we remove that from the result that we got. And then we start checking for the check of humanity. So all post to check, we run a map on it. So we verify if that the person that posted that post item.account ID is a real human or not. So if he is, then what we do is we say you're definitely a verified human. And if he isn't, what I'm gonna do is I'm gonna post the first comment, right? Now I'll show this in action now. Enough of talking, let's get into the real thing. Okay, so what I'm gonna do is I'm gonna upload let's say all posts. I'm gonna make a post. Hi there, it's Harry hanging out here at near social. Let's say I make this post, right? I approve my transaction and commits to the social DB. Now I'll run my code. So as we can see here, I have this, like post in. Now I'm gonna run my bot. So it got all transactions that happened. And now what I'll do is I'll just clear the state for once so I get the latest post that I made in the blockchain, which was mine. So I'll run my code now once again. Node index. So all right. So here's a catch. This is showing Vishali.near as the person who made the last comment. So what it means is the blockchain is taking some time to index my post. Like there's an indexer running in the background. Now we get to the deep stuff. There's an indexer running in the background and it hasn't indexed my post yet. The last post is indexed was Vishali.near. So what we'll do is probably the comment has happened now under Vishali's post. So what we'll do is probably try and see if there's anything under her post. Yeah, you see, Vishali, you're definitely a verified human. This is how it got commented. Now, some of you may ask why I didn't comment under me, because the indexer that we have here, bot.code, where am I indexing this? Yeah, social.index, which indexes the social function, which lies at the API near social API endpoint. It still hadn't catched my transaction. Let's try again once. All right. Okay, it's still taking time. It's still the Vishali.near as the latest transaction, but once I give it enough time, the indexer will run through my function and it'll comment under my post. So that is how basically the bot is running and how you can make comments under people's post.
And while it runs, so just to clarify, if there was 100 posts that came up, the indexer picked it up, you would basically check the condition, which is a verified human that has a message, and you would post on as a comment under all those posts, essentially. Is that how this works, Karen?
Exactly. That's what we do. We check for humanity via the is human variable, and we post under every one of their posts based on if they're a human, we post a verify human message, and if they're not human, we say get registered if you want to vote. That's what we do.
And so in this case, the GeoTV bot.near, like that, the private key is in the environment variables right now, and then ahead of time you set it up by loading it with a certain amount of near that you thought would like require. And so for people at home, like when they're actually setting this up and creating an account, how is that estimated in terms of how much near, how many times to run it? Can you kind of give like the logic behind actually configuring the bot?
So you don't even need to, like get the logic for it. Well, what I'll do is I'll show the exact amount of near that it takes, and then you can make your own estimations based on how many comments you want to make. So let's take geotvbot.near. We run it through the Explorer, and you can see, one transactions happened a minute ago, and how much, like transaction. This is the transaction fee, 0.00086 near. So that's, how much it takes for each transaction to happen. Now, based on this, let's say I want to make a 10,000 comments. So it would require me something around 8 near, which roughly translates to $10 in the current near rate. So for every, let's say, it's really cheap to run. It's like if you want to make 10,000 comments, it'll take you 8,000 comments. It'll take you estimately around $8, $10.
Awesome. And so in this case, they're checking all the feed for is human. They could also swap it out for is a member of a DAO, is a person in the NFT collection.
Exactly. Like, so yeah. So I have declared my verify as human is to check for humanity. Here you can create your own contracts, place your own contracts. If a member is a member of a DAO, if he has done some things on the blockchain, if he has some status, whatever you want, you have your own, flexibility to however you want to index people and put a comment under their post. So you have complete flexibility on whatever you want to do based on filtering these posts. What this basically does is it gives you the ability to index every post that comes in the social DB database.
Awesome. And so you're using the Near API JS like a way to like view and call smart contracts on Near. Can you kind of so you're using the Near API here. Can you kind of explain where that social class came from and how that works? I know you were like doing some new social stuff in here for posting on the social DB. Like where did that come in? If you can run that back.
So it's basically a two-step process. First, you connect to the Near account that you want to make posts from, and that's not enough. Like you're connected to a session right now, but you also need a way to post comments and posts on the social DB platform, right? So that's where the social class kicks in. So what we do is we get the config, which is right here, mainnet, and we also have the mainnet contract social.near on which all of the transactions exist. So we have the mainnet contract, and we export it to the social file, which is right here. Then what we do is we connect to the we don't connect, we initialize our functions in a way that lets us post to these to this mainnet contract, which is social.near. So these are all the functions that help me to I would say modify the data in the contract and allows me to post my transactions. So this set is calling the near function, which allows me to call a set function on the social.near contract with any data that I want. So this is basically how I pass my images and my notifications when I'm making a comment under people's posts. This set function is the key to all the things that I use to post on the platform, whether it be notifications or it be images or it be all the posts. So yeah, that's that's the importance of the social class, where like it's used to post everything, or even you can also use it to get any data, which I'm definitely using when I'm trying to get all the posts, and also index. Yeah.
And so why are all of these in the bot not in one JS file? Like what's the kind of point of the separation and how do they interact with each other?
Okay, so basically that's a design decision that I took to separate these out because these are basically like rule of composability in programming, like you keep things as separated as they can be. But primarily because um these these files all have a I would say a different kind of things that we can achieve with them, or they all have a different purpose. The near file is used to basically initialize your near account, so the name for it. The social file, social.js file, is primarily used to set up functions in order to interact with the social DB contract. And the bot code is where the real magic happens. See, if you want to set up your own bot, the near.js and the social.js files can pretty much the same. You can, copy this. That's not a problem. What you need to do for your special use cases, modify the bot.code file, which is, basically how you will make comments, what basis you will filter on. If you'll make a comment 2 times or how many times you want, like it's all in the bot code file, where all the magic exists to, like comment under people's posts.
Awesome. So you mentioned you two different ways of doing this at the beginning. You mentioned this way and the cron job way. So can you kind of explain what a cron job is and how to set that up, like whether there's like a server involved or like in terms of what is used today by kind of the NDC, like explain that architecture.
Okay, so what is a cron job? Cron job is a kind of uh, if you search it up on Google, it says like cron job. It is like a function that runs every 24 hours. It's a utility, like it's a job scheduler. Let's say you have an API endpoint, right? You have an API endpoint and you want it to execute every 24 hours by itself without any intervention. So what I would do is, rather than clicking a mouse and invocating the function every 24 hours manually, what I will do is, in NDC they are using Google Cloud. So what I would do is I would go to something called Google Cloud Scheduler. So what you can do here is you can schedule it and run a cron job. So what I would ideally do is, let me go back where this is set up as a server, right? Let me just back it up. Okay, so let me go to my GitHub and check this out. Near GOTV bot for near, right? So this is a public repo, by the way. If anyone wants to, run their own bot, they can basically clone this and make their modifications. So here we have the index file. And basically what I did here was I set up a express server which is hosted on an API. Like, yeah, this is what I was used. I hosted basically a Firebase function. I initialized Firebase here, and then what I did was basically then ran an API, and with the use of Cloud Scheduler, I was calling the job on a schedule of every 24 hours. Now, the special thing about it is you can also run it every second, every month, every year, every minute. It's totally flexible how in how much frequency. Let's say you don't have an immediate use case, like you can let your bot run after every 15 days. So that's also a ability that you have, like you can just set up the cron job and forget about it, and it'll be all taken care of in a truly automated way. So
But
that's
in your code, but like no matter what the time is, every time that you run the code, you're keeping track of the latest block height in your state file. So it's so like that's kind of how you make sure you don't repeat indexing the same post. But
exactly.
what so like what were the most, and there's also something called cron cat, which is also on in the Cosmos ecosystem that Mike Purvis made, which lets you kind of do cron jobs on chain and on chain scheduler. Yeah, and near.croncat is the is the thing there. That's something that we'll look more into in the future. Yeah, you just go to the croncat website and then you can click on the bottom. This is this on Cosmos now, but if you go all the way down as well, a lot of validators use this in the ecosystem as well to automate stuff. So I'll click here to visit the old site all the way on the bottom. Click the footer. Yeah. This is another way to do it completely on chain. But no, this is pretty interesting. What were the most difficult things in terms of building this? You touched on notifications, you touched on setting up a server, setting up a wallet, kind of checking for humans and things like that. Like what was the hardest part?
Well, the hardest part here was like getting like doing it in a way which is how I put this. It was indexing this near blockchain in a way that gave me the relevant post that I wanted. So basically, initially I didn't even know how to index the contract. So for that, everyone who wants to know about how to index this, and all the indexers and functions that exist, I recommend them this website, docs.near.org. It has everything, whether you want to build on boss, understand the smart contracts, understand everything. You can probably everything that relates to the near blockchain building stuff. Everything is here. So what I did was I went on the social.index documentation, and learned on how we can index this in order to get all the relevant data. And then when I got it, I also had to figure out how to filter it according to my requirements. So yeah, getting this data and like verifying the humanity, I think, was the most challenging part of this whole thing.
Yeah, and definitely would like to get into an indexing session later in the series. For those who don't know, actually indexing is a huge problem. A lot of applications build this infrastructure. Midbase has its own indexer. Pagoda provides AWS like near lake solution where you can use and leverage AWS to build your own indexer. Indexer.xyz has one especially for like NFT use cases, and Pike Speak as well. And so yeah, a lot of different people are building indexing solutions, but especially on the social.near contract where any type of data can be set, and you have profile information and you have comments which are associated with a post. It's getting kind of tricky to index here. So you'll see, especially with the combination of a social graph and maybe a DAO proposal, a lot of people are running into this problem of how do I effectively index, especially when relating to the social DB. So yeah, I feel your pains on that front as well. And you might see also different indexing. Pagoda on the near.org gateway, they use Query API, which is an indexer as a service that they're rolling out. And so you might see the differences in feeds between near.org and in near.social because they have different indexers in that respect. But yeah, hopefully Queer API, Rashan could come over there to give a session a little bit later. But is there anything you'd like to add before we kind of switch on to components and widgets and apps on the blockchain operating system now that we went over kind of like the automation side of the social DB?
Well, one of the things that I would think people to dig in is before we start on to get onto the widgets, is basically how to index these these contracts. So I would really encourage you guys to go to docs.near.org, search for indexers, and know all about it, because when I started building these indexers, I didn't even know like how indexers worked and what was the concept of an indexer, because um in the Web2 world, which I come from, there is no concept of like constantly listening to these transactions. What we have there is webhooks, which are completely different. But these indexers are much more powerful in capturing all of the data that is being appended to the blockchain. So this can really empower you to have all the data that you need on your users, on the transactions that happen, to really kind of shape your applications in a way that, in any way you want, basically. So yeah, I would really encourage people to dig into indexers and learning about them.
All right, awesome, awesome. And so like the next part of this is going to be focusing on some components that were recently built, still being built out, but I think it's a great kind of opportunity to showcase. There's a lot of applications in the near ecosystem that are maybe open source, maybe not open source, or at least all the contracts and the functions can be seen on Near. And a lot of people are essentially rebuilding these applications on Boss. And one of them is a pretty kind of unique use case that was pretty fast to prototype based on existing components, and that was Haven Swap. So there was an OG collection on Near called Antisocial Ape Club, essentially a board pixel monkey collection. And in their time, they formed Antisocial Labs, where they provided a lot of services to different like NFT communities, especially when the NFT era was booming. And they did something called Haven Swap. And so they essentially kind of let us rebuild this on Boss, gave us the source code for the contracts as well. And what it is, it's peer-to-peer trading. Just like in RuneScape where you would barter, you can barter your NFTs directly. And so there are kind of like a few components like NFT selector that was already there. They kind of made this easy to build on Boss. So Harry's been actually like working to essentially get feature parity with this on Boss, so other people can fork and we can have this kind of barter function. But can you kind of break down that process, the mission at hand, and like where you're at? And I think there's also some extra additional functionality that isn't on Haven Swap that really leverages the social graph, like being able to see someone's profile or being able to give kind of those notifications that he used in the bot before, but this time natively within Boss.
Right. Got it. So what we're gonna do is I first shout out to Jutsu, where I build all of these components. It's a really great platform if you want to build on Boss, or you are building on Boss. It's the fastest way to build out components. So here is where I built this marketplace to kind of swap your NFTs, or even give someone an offer. Let's say my guy Shot, I really like his NFTs and I want some of them. So what I will do is I will search his address, right? And I got your profile, right? So that's the special part. Let's say I want to go to your profile and see what you're all about right now. So I guess, yeah, still I think this is in progress. I need to modify this, but yeah, I got all of your NFTs that you have. I see interesting some Zap NFTs that I want. So what I'll do is I'll just click on those, and I also want your this NFT, pretty cool ones, right? I Let's say I want to offer you $1 for them. So I'll click on whatever whatever amount you want. You can click in here, and then
Wait, hold on. You don't want to offer me any NFTs? You're just gonna try to just buy them from me? You don't want to like I like the one in the corner. Can you offer that to me?
the corner. Okay. You want this?
Yeah. That's a cool one. You got 3 of them. You
All
don't
right.
need all of them.
So yeah, so this is a dual functionality basically. You can either offer money in Near, or you can basically trade your NFTs. So what happens is, as soon as I click this button, I'm able to review, what all it is I'm offering and what all it is that I'll receive. So as soon as I click on this offer, what happens is I see all of the things, as a single transaction that happens. So, what I can basically do is click on confirm, and there's multiple calls happening to the respective contracts here. So as soon as I
Can
approve this,
can you go into that a little bit? Okay, and so you could have gave me money. You decided not to. He was being cheap. You can both offer and also give money. But if you can look into this, because there was a bunch of different calls happened. I think there was a call for each NFT, in
yeah.
addition to the offer. So if you want to break that down real quick.
All right, so let me, I can do this all day. Let's do it again. All right, so I wanna offer you an NFT, and you see, you got these because I transferred them to you. These were mine, and you have yourself a trade, which you can. I think these images need to be kind of modified, but that's still in progress. But what you can do is, okay, I'll show you the contract on how is that happening. Let's say I want to give you my registered hacker NFT, and the shard dog one, and I want your this NDC endorsement. Okay, let's offer this up. So basically, yeah, we'll see the transaction details on that page. So first is the send offer transaction. So what this does is, it sends you an offer which you have an option to either accept or reject. Like, you have complete flexibility. Like, if either you want it or you don't, you'll have the option in your account to accept or reject my offer. But what I'm doing here is, I'm not offering you these NFTs. I'm directly transferring them to you through the contract that they were minted from. So min.sharddog.near gave me that sharddog NFT, and comic.sharddog.near gave me their NFT. So I'm just calling, the NFT transfer function. And this is also interesting for the people who don't know. When you're looking into the transaction details, this is the contract that you're executing. And this is basically, the function that you're executing. So I want to show you guys something interesting. So if you go to near blocks, right? And it has a new, new kind of functionality where you can also see the contract methods and the contract for the contract that you're executing. Let's say you don't even need the code for it now anymore. So let's say I go to swap.generaldrop.near, right? So I can go to, you see, I have executed my contract just now, and you can also go to the contracts and check all the contract methods that this contract has. So, it's kind of like, if you're stuck anywhere, you cannot see which method to execute on a certain contract, you can just come here and, search for the contract, and, you'll basically get all the options that are available, all the functions that are available to execute, basically. So yeah.
And then since we're in the context of actually, there's a few questions I have, but since we're in the context of like kind of taking the existing application and kind of reverse engineering to build it on Boss, another thing that is done is, like, in a contract, we often look at the transaction history and then the execution plan. So if you can show that on near blocks to kind of get an understanding of what a successful transaction looks like, or we go to the actual application and spend money and actually commit the transaction. So you can see here like different offers on the original contract, and then if you go to execution plan, you can on that tab you can see what the actual actions is. That way you can see what's going on here, so you can get an idea of like what that looks like. And why was it an NFT transfer for those, or like, because you're actually transferring in the offer. When I offer something to someone, I don't actually transfer it to them. So can you kind of explain that?
Okay, so what we did was we basically, took the Haven swap functionality and, kind of like replicated it. So what those guys did was your own NFTs, they are not up to offer. You can just, you can just transfer them to the other person if you want. And for the NFTs that you want from another person, that you send basically an offer for. So basically, it's not like, you're selling your NFTs. It's basically you're asking the other person that I want this and I'm willing to offer this price for this, or I have, just transferred you some NFTs. So can you please, give me the NFTs that you have, or you have another option now. So and these things are
Wait,
done.
I'm not, I'm gonna check the contract, but I'm pretty sure it doesn't work like that, to be honest. I'm pretty sure like you offer. Let's
Let's go to Haven Swap then.
see. Let's double check, because that's a weird implementation. Like if you go in here and you execute a call, um pretty sure it's an offer. So there's a thing on like there's a thing on Near where you can actually list on multiple marketplaces, and there's like an NFT approve function. So let's look into
So
that.
so if you click on offer here and confirm, what it's gonna do is it's executing a transfer here. So the Haven Swap functionality, it's built like that. If you want to give your own NFTs to a different person, what you do is, you just trade them out. You just give them out, like to whoever you want for. And if you attach some Near to it, essentially what you're doing now is you're sending money to them, like in Near, and also sending the NFTs. So what will happen is there will be a mass transfer call in which you will get 0.2 Near from me, and you'll also get the NFT. It's only when I start asking you an NFT is when the offer functionality clicks in. So when I want an NFT from you, that's where, like the send offer function kicks in. So basically, that's the overview of it.
What? That's kind of whack. I thought it was like upon. I didn't realize I was sending NFTs. Oh man. Okay. I'm gonna look back into that. But if you can kind of go into the implementation, man, I think I sent some good NFTs to some people testing it out. I'm not gonna lie.
Oh,
All right, and then if you can go into the trade real quick, and then we can quickly kind of go over the code.
okay. So you wanna do a deep dive into the code. Okay. So first of all, I'm not trying to scare anybody here. Those people who are not, familiar to Boss. So basically, it's a decentralized way to build front ends. So like let's say you have your React code. This is basically React code, but broken into several micro front ends. So, but the special thing about Boss is you don't need to set up a repo. You don't need to set up anything. You can just create a new file saying hello, and just start building. You don't need to set up anything, and you get all the functionality as you would get in a normal React application. So that's a just quick tutorial on Boss components. And now we basically have the NFT trade component that's on the top of it, which has the swap and trade UI in tabs. And then you have the NFT transfer, which has basically, all of the, I would say, code that, has the logic. So, okay, so let's do this. So refresh this. Okay, so first of all, what we do is we have an NFT selector component. What it does is when I insert my account ID, so what I'm doing here is I'm inserting my friend Plug's account ID inside this component. So what it does is it fetches all the NFTs from his ID for me to preview, like how many NFTs does he have, right? So that's the first, first piece of functionality. So first we need to list the NFTs from both sides, what I have and what the other person has. And then I also, here I have the functionality to, like initiate an offer. So this, I have this all, like this whole functionality for offering, I have in another file called new offer.jsx. So basically what I'm doing here is I am building the call, like I had to create a separate function in order to execute all the transactions, because this is a pretty long list of transactions that are taking place. So as you could see, like the page that I showed you, there were multiple transactions happening, and I need to make them in one go. So what I did was I took an all transactions array, and based on the conditions that we have in front of us, I'm pushing this to the all transactions array. So I'm executing multiple all transactions.push. And in the end, what I do is I call those transactions by the near method. Now, this is something special. You want to interact with Web3, you don't even need to initialize your Web3 functions. You already get near.call and near.view to, like interact with our near blockchain. And as Jutsu platform is also, building their infrastructure out to interact with different blockchains. So soon you'll be able to interact with Ethereum and Optimism blockchains. Likewise, you're doing it with Near. So you get all of these. You get also a storage function where, you can just use it like a local storage where you can store, key value arguments, key value pairs. So that's one of the things. So we call this transaction, and then like we execute it, and then we have then we can preview. We can basically preview that inside the trade tab. And where do I have our trade tab? We have that inside our order file. Yes. So what I'm doing here is I'm getting the transaction data for all the transactions that I have, and then, fetching the NFT data to, just render all the transactions that I'm doing. So it works in this way. You can reject the transactions that you are making an offer for, but you also have an accept option to accept the transactions that are being offered to you. So I, send plug like a couple of NFTs. I can reject that to send to him, but the NFT that he tried to send me, I can either accept it or reject it. So it's a pretty.
What happens with that though? Because that was an NFT transfer, and like if you reject it, like does it send it back, or what actually does it reject?
So it's interesting. So these NFTs of yours, what happens is you have also attached some near to it. So this near is being stored in an escrow contract that's in swap.gendrop.near. So the near that you have attached for the offer isn't available to you anymore. It's inside the escrow contract, which is being stored there. So as soon as you click on the reject, you'll get this near back to you. So that's how the infrastructure.
Okay. So the transfers were to the escrow contract as well. So all the NFTs are all held there and they're referenced by a hash.
Exactly.
Okay, for the trade. Okay, that makes sense. So it is a barter contract based on escrow.
Exactly.
Makes sense. And I just want to clarify too, also there is ethers.js support already on Jutsu and on Boss already. So you can interact with like Arbitrum, Optimism and all that as well. It's just not in this use case because this is only for Near. But yeah, can continue with the
yeah, I mean, then you're able to, process then I'm basically fetching the data for all of them and then, rendering it inside a UI. For React developers, I would say, just give this a shot, give this building, go to jutsu.ai and, like try building on some boss components. It's pretty great, how much flexibility and time you'll save building UIs. Both Web 2 and Web 3. So what I'll do is like pretty, React way to do. I just mapped out all the transactions, and this is the UI that I got through it. I'm, mapping out all the data that I'm getting, and, have the options to either cancel the offer through the cancel offer function, or, execute the accept and, execute a couple of transactions to either, like get the NFTs that are being offered to me. So yeah, that's about, the code about this swap component.
Yeah, and can you kind of because there's a lot of familiar components I see here, and this is what's great about Boss. You can reuse a lot of things going on. So can you kind of outline the NFT selector component? I see you have an account profile like card component, maybe even the tabs as well, and kind of like what you leverage to build this quickly. And also like why you kind of redeployed some of these components under your name and customized them versus just like referencing what was already existed.
Okay, so this is where it's gonna get great. You have your npm in your React, right? npm wherever you want to use other people's code, like they have to publish it and, go through all of that pain. You want to use someone else's code in Boss? What you do is you go on the search tab. You get the option to fork, open, and extract anything you want. So let's say I want a profile code, right? Let's say I want my profile image that I have on Boss, or I want my account profile. So, I get the option to source this guy's code. I don't even need to write it anymore. What I can do right now is I can fork this up and change this according to my needs. So this is the slow way of, getting their code. What you can do is, let's say I click on profile again. I go to this guy's and I just click on copy. Then what I do is I go back to my code environment, and how you're able to leverage other people's widgets are this, right? Widget and the thing that I copied, the source. Okay, so yeah, I got the whole thing. Yeah, so widget and source. So I'm able to get their whole, and you also have the ability to insert props now. So how does that happen? So I do a props thing. So I don't want my ID to be here. I want Plug's ID to be here. So what I'll do is I'll just type in his address. So, that's we got his ID here now. So this is how, this is ultimate level composability, which which Web 2 front ends cannot have, because this is how, we are just fetching the code. Basically, we are not fetching the data dynamically here. We are even fetching the code dynamically in order to render it on the UI on demand, on the fly, everything happening in an instant. So that's how, we build UIs on Boss.
Yeah, and I wanted to go over like a few concepts that you touched upon. So speaking of like composability, you forked the NFT selector component that uses props, but then it takes what happens inside of the NFT selector component, and then it passes it back up to the parent. So you can essentially like call it within the offer in the swap escrow contracts. So can you kind of explain how that works, how you're able to take what's being selected within a child component or a component referenced in another component, and then take that state and like bring it back up to the parent? Because that's like for a lot of new Boss dev, that's kind of a interesting concept.
Okay, so let me touch on that now. Amazing. So what we do now is we have this on change function, which I'm getting from the top, like from the top of the tree. I'm drilling down the on change prop inside this, and I'm calling it here every time I click on an NFT. So it gets functional when I have this NFT trade UI, and I'm using this NFT selector, and I'm passing this on change function. So every time I click click an NFT, basically, I get all the details from it down from this component up to this up to my, NFT transfer component through this on change function. So I can, basically get all this data and send it to my states and call it in an escrow contracts and do whatever I want with it. So there's a double data passing. So you can either, drill down props, and you can also get up data through, your on change functions, pretty much how you do it in, React and all that.
Awesome. And then so you take a lot of this data and you essentially there's a lot of kind of mapping involved, especially when you were looking at the offers. Can you kind of briefly go over like how mapping goes? And then at the same time, you're also keeping track of buttons with state and having like conditional pop-up. So can you show a little bit, dive deeper into like the rendering of pop-ups and then also like the mapping of components? Because these are basic concepts, but for just all the new boss devs coming up.
Sure thing, sure thing. So you get an option to initialize states. So in React, what you do is, let's say I want a value and set value. What I do is I execute a use state. So this is how I would do it in a Web2 world. So what I do in the Web3 world is I initialize a state called state.init. What you have here is a state, I would say state class, which has a couple of options. State.init. It can this thing state.init is the same thing as init state. So you get this option to initialize the state that you want on the top of your file, right? Then what you have is you can update the state by calling state.update. So this is how, I'm able to modify the state. And how does it look? Let me show you guys. So I'm basically logging the state changes in my console. So let me show you. I select an NFT. And where do I have? I have all the NFTs that I'm sending. I'm storing in a state called send NFTs. So as soon as I start clicking NFT, see what happens. I get all of the NFTs that I select here, right here, access to me, right as a state would in any kind of Web2 framework. So this is how state works here. And I'm kind of, I have my offer button here, and I'm able to, have like a condition based on if I want to enable offer or not. And based on that, like I kind of enable or disable my offer button. And then as soon as I click on this, I open a pop-up, which is essentially also another component, which is called a new offer component. Here I'm using a model component, which is used to, render the pop-up. So the model component is here, which is basically, some kind of styling that allows you to center the div inside your viewport, and also, just render the body inside it. So through this, I'm able to achieve this UI where basically I'm able to render a pop-up, and the UI inside the pop-up, I'm getting it from new offer component. Yeah, so that's all about, how I'm rendering and using these pop-ups and how states are leveraged inside Boss.
Awesome. Now this is great to see. And it's pretty cool, the composability. I know NFT selectors that use just in your call. I know NFT selectors that also use Mintbase's GraphQL API as well. So there's a lot of different ways you can leverage it, but the functionality is the same and can be kind of swapped out. So that's pretty cool. You went over pop-ups. Can you kind of outline mapping a little bit? And also after that, like a little bit about the folder structure. I know Jutsu kind of displays it nicely, but how that's set up and how you kind of modularize your components.
Okay, so let me cross out everything now in order to, have a kind of fresh slate for anyone who's coming in. So what we have here is, let's say I want to build an app, a really big app. What I don't want is a flat tree structure. I want all of the files to be very kind of structured in a way. So what I do is I don't have an option to create a folder here, but see what happens. The name of my app, I click on new component. The name of my app is, let's say, tree NFT, right? Tree NFT. And I have an index file, the entry point file. What I will do is I'll click dot, and I'll say the name of the type the name of the component. So what will happen is when you click on a dot, before that, a new folder is created. So let's say now I want the homepage UI of it. So what I'll do is tree NFT. Let me make sure, yeah, I'm typing the name right here. Tree NFT. So this is the first folder, and this is the second folder, homepage, and I have index.index. So it will create two folders and a file deep inside them. So this is what will happen. So this is basically, how tree structures work, and you can, sort your files pretty nicely inside these, inside the boss environment.
Awesome. Yeah, another great feature about the Jutsu as well. Yeah, we're coming over time. Went over a lot of things from how exactly to set up a new social bot that interacts with the social DB, primarily the post and the comments, and then also went over the NFT selector, which leverages an existing contract that was forked and different components like NFT selector, account profile card, has concepts like conditional rendering and changing state between children and its parents. Is there like kind of going back to how we finished the last one, like what was kind of the hardest part about the NFT selector, and then we can kind of recap in terms of closing notes.
All right. So I mean, there were a lot of hard things about this NFT selector. Well, one of the things was how are you gonna, know about the values that are being called in the contract. So for that, I would advise users to, like see the implementations of the contract that other people are using. Let's say you want to implement something in the social DB contract. And a lot of the times, the most prominent error you'll face is you'll either mess up the deposit value, or you'll either mess up, the gas it'll take to run the function. So what I recommend is, as all of this is open source, publicly viewable code, what you should do is you should, go on to other people's code and see how they're executing their transactions. Because it'll really, put things into perspective on what you're doing wrong, or maybe you're estimating the gas fees wrong, or maybe you don't have enough deposit or anything, just so the hardest part here was, like knowing basically, on how to run the functions and transactions properly in order to, get the results that you want.
Okay, speaking on this, so before I gave actually the source code to the contract, there was like we saw kind of here the offers were calculated by hash. So how was that calculated here? And what was your methodology for trying to figure out like how they did the hash, not having the source code?
So hash was a pretty difficult thing to calculate. So there's a hash related to each transaction, which, which becomes a unique ID. And what they were doing was they were using crypto API to basically calculate the hash. So what I had to do was, basically Boss doesn't have the crypto API implementation and built into the platform. So I had to come up with, I leverage chat GPT, but I came up with a unique, way in native JavaScript on how to come up with unique hexes. This is like generate random hex bytes, and this function gives me a unique hex based on the value I gave it. So let me show you guys how does that happen. So this is a unique hex of size 40. So this is basically, like how the hex is calculated through a hex function, basically. Hello?
Yeah, that's pretty cool that you built that natively. So you're really just kind of querying, you're basically querying all the old like you don't need to calculate the hash in order to retrieve the past offers. You just need it to create kind of the offer ID essentially.
Exactly. In order to initiate an offer, you need a unique hash attached to it, so it's, uniquely identifiable.
Okay, and then when it comes to gas estimation, this is something that I also find really hard. So how did you try to figure that out before you saw the contract, and then like after?
So as a rule of thumb, what I try to give is like what I try to do is like there's a concept that people will understand only after they've worked with boss. There's something called near, and there's something else called octonear. What is a octonear? Octonear is 10 to the raised of power of 24. Octonear is actually 1 near. So that's how near calculates its gas fees in octonear. So as a general rule of thumb, what I try to do is I try to attach at least I would say 100 T gas, which equates to how much? 3, 3, 6, 9, 12, 15, yeah, 15 zeros. 15 zeros after one. So that's how much typically all the contracts require in a gas function. Now gas depends on how much compute power a function is taking and how much it's spending on its how much it's like appending to the blockchain. So that will be your gas fees. And let's say you're making a transfer, so your deposit will depend on that. You have to deposit at least 1 octoneer, which is like a really small amount, inconsiderable, but you have to deposit it for each transaction. But if let's say what I was doing here is I was also sending my money to the escrow contract. So the amount that I was offering up for their NFTs, I'll multiply it. Let's say 1 year, I'll multiply it by 10 to the power of 24, which becomes 1 year in octoneer. So that's basically how I basically tackle to calculate the gas and deposit values.
And so based on that, you didn't need to see how they calculated it. It just worked.
Yeah, pretty much.
Okay, lit. Awesome. Awesome. Yeah, we're well over time. Is there anything you want to kind of close off in for people viewing at home, or for the media editors turning this into shorts? You want to give some fire bite-sized TikTok content?
Okay. So I mean, I would say as a closing note, Boss is the next thing in Web3. It's the best way to create Web3 decentralized components faster than ever you could do in Web2. So I recommend you all checking it out on jutsu.ai and just getting started with your journey in development to Web3.
I see everybody. Check out Jutsu. Till next week. Bye.
All right, guys.